Right, okay, we're looking at Pythagoras and trigonometry here, and whilst trigonometry goes into non-right angled triangles later on, okay, at the moment you just want to be thinking about right angled triangles. Okay, so it says calculate the length AC. Now the difference between Pythagoras and trigonometry, Pythagoras, okay, has to be with right angled triangles. Trigonometry can be used with right angled triangles, but can be used with any triangle actually. But essentially, if an angle is involved, use trigonometry. If an angle is not required, use Pythagoras. That's kind of a rule of thumb. And so, if I'm finding AC, right, I've got two sides of the right angled triangle and I need to find a third. Now, Pythagoras' theorem looks something like this: a squared plus b squared equals c squared. Okay, where c is the hypotenuse. Now the hypotenuse is opposite the right angle. It's the longest side. And so what we have here is 8 squared plus b squared, because that's going to be b, equals 21 squared. And so therefore b squared equals 21 squared minus 8 squared, which I'm going to use my calculator for. Alright, so 21 squared minus 8 squared equals 377. And I don't want b squared, I just want b. And so therefore I need to square root that, and I end up with a 19.4. Okay. Now trigonometry, I'm going to change to green, here we go. Trigonometry involves an angle. Now that's the angle I'm trying to find, ACB. Okay, and this is opposite my angle and this is the hypotenuse. And so therefore you should know SOHCAHTOA, or however you want to remember, SOHCAHTOA. Alright, however you want to remember it, there's rhymes and things to remember it. Okay, so this one uses opposite and hypotenuse. Opposite and hypotenuse are the two I've marked. Now I could use what I've just found, but just in case I've made a mistake, I'm not going to. Right, so I'm going to do sine of the angle, right, which I'm going to call that Greek letter you've possibly seen called theta, equals the opposite over the hypotenuse. Now then, to rearrange that, I do sine to the minus 1. So whenever I'm finding an angle, right, I use shift sine, the inverse of sine, whatever you want to call it. Okay, so here we go. Now I need my calculator again. Shift sine 8 over 21, and I go and I get 22.4 degrees. Now over here we've got an angle involved and I'm trying to find what QR. So here we are, I'm going to call QR X. Alright, now again I need to label my sides. I've got the hypotenuse and I've got this time the adjacent. So in SOHCAHTOA it's Ka. Alright, so we've got cos, which is cosine is the full word really, of x over 16. Now you always do it's adjacent over hypotenuse. Okay, so we're going to be doing 16 times cosine of 63. Alright, which equals 16 times cosine of 63, and I get 7.3 centimetres, which looks about right, doesn't it, to be honest? Okay, so there we go. Now if it was the other way around, if I was trying to find the hypotenuse, then I would be divided by cos 63, but I'm not, so there we go. Alright, so just be careful and use SOHCAHTOA or however you remember it.